Now, what if we wanted to estimate the percentage of residents in a particular state that were smokers? Then, maybe it's 24.4%. What if we wanted to estimate that to within 3 percentage points? If we wanted to know what sample size we should take, we could use a sample size formula. Well, here is the sample size formula for the case where you're estimating the difference between two population proportions. Okay, so there's the formula, and I'd like to just kind of go with here. It's an N, and so what we're going to do in this case is whatever N we find from this formula, we're going to let that be both the population size for the first group that we should select and the population size, or the sample size, I mean, from the second group. So we're going to let them be the same. And they're based on this formula. I would normally write this as P1 hat times, and this is Q1 hat, plus P2 hat times Q2 hat. And then get that sum, and then add that sum together, and then multiply by the critical value divided by the desired margin of error squared. Again, I'm not going to derive it, but this formula comes from directly. The margin of error formula is given in the confidence interval formula, and if you just set E equal to that formula that they give you, this is what it would come out to be. All right, the other version of this is that if P1 and P2 are the same, then here's the formula. You don't have to do all of this stuff. You can just put in 0.5, because the largest this sum's going to be is 0.5. Anytime you multiply a population proportion P1 by its complement, 1 minus P1, the maximum value of this is going to be 0.25. And if this is 0.25 and this is 0.25, then you add them together and you get 0.5. All right, so if you don't have P1 hat and P2 hat from a previous study, just go down and determine the sample size using this version of the formula. All right, so down here is our problem. I'll show you how this works. We'll read the problem. And part A would be if P1 hat equals 0.275 and P2 hat is equal to 0.231. So let's say that we have estimates from 1999 on a similar study that was done. Educator wants to determine the difference between proportions of males and females who have completed 4 or more years of college. What sample size? So this is what tips it off for you. What sample size? And another way to say that is to find N. So we're looking for a sample size. The formulas above make sense for that. She wishes to estimate the estimate to be within 2 percentage points. Okay, plus or minus 2%. This is the margin of error. We will report this as a decimal into our formula. And the other thing is the C level is equal to 0.90, 90% confidence interval. The sampling distribution will be the Z distribution. And so the critical values, something that you have to come up with, is, let's see, 90% on the inside. That means 10% on the outside, or 5% in each tail. So this would be inverse norm of 0.05. And I think you've done this enough times that you might even have this one memorized. Plus or minus 1.645. You can either use 0.05 for this one or 0.95. 0.95 will give you the positive one. 0.05 will give you the negative one. Okay, so she uses estimates from 1999, and here were the estimates for male and female. And so Q1 hat is 1 minus P1 hat, and that's equal to 0.725. And Q2 hat is equal to 1 minus 0.231, which is 0.769. All right, now we're ready. So N is equal to, we're going to take P1 hat times Q1 hat plus P2 hat times Q2 hat, and then we're going to multiply it by our critical value for Z divided by the margin of error and square that number. So now it's just a matter of plugging everything in and evaluating. And remember, we're looking at a sample size here. So when you evaluate this, you always want to round up to the next integer. Round up to the next integer. Don't round mathematically, but always round up. All right, so we're just going to plug all these in. We have 0.275 times 0.725 plus 0.231 times 0.769, P1 Q1, P1 or P2 hat Q2 hat. All right, and we have the critical value here. Right, so that's the 1.645. You don't have to worry about the plus or minus sign because inside this fraction we're going to square it. Squaring makes everything positive. And then finally the margin of error goes down under. That's the 0.02. So let's go ahead and calculate this. 0.275 times 0.725 plus 0.231 times 0.769. Close that off. And then we're going to multiply by 1.645 divided by 0.02. And don't forget to square that. It's only the last thing. All right, the sample size should be 0.02 is a very, very small margin of error. And so you're usually going to have, sample sizes up in the, thousands for this, or about 1,000 or whatever. Actually more than that. All right, so I'm going to write this number out. 2550.523273, and we always want to round up, so 2551. And there's the sample size. All right, the next one says she does not use any prior estimates. So this would be related to this one here. If prior estimates are unavailable, we're going to use this formula as opposed to this one. So for part B, we don't have to do these calculations of Q hat here. We simply write the formula out, 0.5, and we've got the Z of alpha over 2 over E, and we're going to square that. No inserting of P hats and Q hats, we just write 0.5. And then we've got 1.645 divided by 0.02, and that's going to be squared. This sample size is actually going to be higher than the other one because this 0.5 is the maximum that you can get when you add P hats and Q hats in this way. So let's see what it is. Yeah, so Gabby asked if the Z of alpha over 2 is always going to be positive in the equation, and it really doesn't matter. You can use the positive one or the negative one because of the squared there. Whatever this is in the end, positive or negative, you're going to square it, and when you square something, you always get a positive number. But it's simpler to put the positive one in, so I would put the positive one in. Okay, so 0.5, and then times 1.645 divided by 0.02, and then square that. And you can see it's much larger. So 3382.53125, and so N equals 3,383. All right, so what sample sizes should you have? And remember up here, it says the n that we calculate is going to be equal to the sample sizes that we need for both of our groups. And so when you get this number here, N1 should be 2551 and N2 should be 2551. Over here, N1 should be 3383 and N2 should be 3383.